Hi, welcome to Maths Academy. Today's topic is quadratic equations. So first of all, what is quadratic equation? An equation of the form ax square plus bx plus c is equals to 0 where a is not is equals to 0 is called a quadratic equation. Here a, b, c are coefficients. Here b, c, a is the coefficient of x square, b is the coefficient of x, and c is the constant term here. Here a should not be equals to 0. What is the reason? If a is equals to 0, what will happen? If a is equals to 0, this total term will become 0, right? So this total term will become 0. Then we left with here bx plus c is equals to 0. It is not a quadratic equation. Here the degree bx plus c is equals to 0. The degree is 1. It is a linear equation. So that's why here the condition is a should not be is equals to 0. Right? Here ax square plus bx plus c is equals to 0 where a is not is equals to 0 is called as a quadratic equation. That means for this quadratic equation the roots are exactly 2. It is not more than 2 and not less than 2. What is the reason behind that? First of all, we'll take one example. After that we'll tell you what is the reason why can't it is 3, 4, 5 like that. Here I am taking one example for this quadratic equation, that is x square minus 5x plus 6 which is equals to 0. So if I want to solve the roots of this quadratic equation, already we learned in our 10th class, we have splitting the middle term and also we have quadratic formula method, right? So how we can split the middle term here? X square minus 2x minus 3x plus 6 which is equals to 0. Minus 5x can be written as minus 2x minus 3x. So if I take here x common, it is x minus 2, and if I take minus 3 common, it is minus 2 which is equals to 0. So in both we have x minus 2. So if I take x minus 2 common, it is x minus 3 which is equals to 0. Now the product of these two terms is 0, means either this one 0 or this one 0. Then only you will get the product is 0. That implies x minus 2 is equals to 0 or x minus 3 is equals to 0. So if x minus 2 is equals to 0, x is equals to 2. If x minus 3 is equals to 0, x is equals to 3. Means here what are the roots for this quadratic equation? 2 and 3 are the roots of this quadratic equation. 2 and 3 both are the roots of this quadratic equation. So here we got two roots. Otherwise we have one more method, that is quadratic formula method, that is x is equals to minus b plus or minus root over b square minus 4ac by 2a. Already we studied how we got this formula from this. Okay, now we are not going to derive this formula. Okay, we know already this one, x is equals to minus b plus or minus root over b square minus 4ac by 2a, right? So if I substitute here a value, a is equals to 1 and b is equals to minus 2, if I minus 5, if I compare both, minus 5, and c is equals to 6 here. Okay, now if I substitute in this, I will get again two roots. One is minus b plus root over b square minus 4ac by 2a, and one more is minus b minus root over b square minus 4ac by 2a. So like that we will get. So any of the method we can use to solve the roots of a quadratic equation. So here my question is, why can't 3 roots and 4 and so on? So now we are going to see that we are going to consider ax square plus bx plus c is equals to 0 quadratic equation, we are taking let alpha comma beta comma gamma are the roots of this quadratic equation. Let us take here we are considering that alpha, beta, gamma, three roots for this quadratic equation. We'll see what will happen if I take three roots for this quadratic equation. Now, here we need to consider that all three are unequal. Means all three are different. All three are different. So that is the condition. Now here, if alpha, beta, gamma are the roots of this quadratic equation, already we know we can write like this: ax square plus bx plus c, which is equals to otherwise. So here ax square plus bx plus c is equals to 0. For this quadratic equation, alpha, beta, gamma are the roots, means we can substitute these three roots in this quadratic equation. So what will happen if I substitute alpha in this equation? A alpha square plus b alpha plus c is equals to 0. Let us take this is equation number 1. Now let us substitute the second one, that is beta. A beta square plus b beta plus c, which is equals to 0. This is equation number 2. Now the third one, that is a gamma square plus b gamma plus c, which is equals to 0. This is equation number 3. Now here what I am doing, I am going to do here 1 minus 2. What will happen? Let us see if I solve 1 minus 2. 1 minus 2 means c will get cancelled. So here if I take a common, alpha square minus beta square. In this, if I take b common, it will become alpha minus beta, which is equals to 0. Minus 0 is 0 only. Now if I take again alpha minus beta in these two common, if I take alpha minus beta in these two, if I take common, so what I will get here? A into alpha plus beta. How we got? Alpha square minus beta square can be written as alpha plus beta into alpha minus beta. So here already we have taken common alpha minus beta, so which is nothing but b, which is equals to 0. Now the product, again the product is 0, means either this one 0 or this one 0. But if I take this one 0, what I will get? Alpha equals to beta I will get. But in the starting itself, what we discussed, alpha, beta, gamma, all three are different. All three are different. So here we are getting that alpha, beta are equal. So in order to get the product is 0, only this one is 0, not this one. Not this one is equals to 0. Because if I take this one is equals to 0, I will get alpha equal to beta. But here we are taken alpha, beta, gamma, all three are different. Right? So here I am taking alpha a into alpha plus beta plus b, which is equals to 0. This is equation number 4. Here alpha minus beta is not as equals to 0. Already we know what is the reason. Right? Now let us see what will happen next. If I subtract 2 and 3, what will happen? 2 minus 3. What will happen? Again, if I take a common, beta square minus gamma square, beta square minus gamma square. If I take here in these two, b common, if I take b common, beta minus gamma, and here c it cancels here, which is equals to 0. Now again if I take beta minus gamma in these two common, beta minus gamma, so what I will get here? A into beta plus gamma plus here already we have taken beta minus gamma common, so which is equals to 0. Again if you observe, beta minus gamma into this one means the product is 0, means either this one 0 or this one 0. But again if I take this one 0, I will get beta equal to gamma. But here beta and gamma are different, so we don't have to take this one 0. We have to consider only this one is equals to 0. Means a into beta plus gamma plus b, which is equals to 0. This is equation number 5. This is equation number 5. Now here we are going to do now 1 minus 3. Let us see what will happen. 1 minus 3. What will happen here if I do 1 minus 3? Here 1 minus 3. So if I take a common, alpha square minus gamma square plus beta into alpha minus gamma, which is equals to 0. Again, if I take in this 2 alpha minus gamma as common, so what I will get, a into alpha plus gamma plus b, which is equals to 0. Again, this one is not is equals to 0, already we know, so that implies this one only 0, that is a into alpha plus gamma plus b, which is equals to 0. So this is equation number 6. This is equation number 6. Now just observe here, just observe again if I subtract 4, otherwise if I subtract 5 from 4, what will happen? If I subtract 5 from 4, whatever it may be, either 4 from 5 or 5 from 4, what will happen? Now let us see. So if I subtract 5 from 4, so what I will get here, bb gets cancels, bb gets cancels. So if I take a common, so what I will get if I take a common, 4 minus 5 I am doing here. Okay, in these two a is common, so if I take a common, so what I will get, alpha plus beta minus beta means plus beta minus beta cancel, alpha minus gamma we will get, alpha minus gamma, and bb gets cancels, so which is equals to 0, which is equals to 0. Now just observe here, just observe, this is very very important. Now a into alpha minus gamma is equals to 0. Again the product of two terms is equals to 0. Very interesting here. A into alpha minus gamma is equals to 0 means either a is equals to 0 or alpha minus gamma is equals to 0, or alpha minus gamma is equals to 0. Now if alpha minus gamma is equals to 0, then what will happen? Again we will get alpha equal to gamma, right? This one 0 and this one 0. If I take alpha minus gamma 0, alpha equal to gamma I will get. But that is not possible because we are taken alpha, beta, gamma are different. So only the case here we need to consider, that is a is equals to 0. A is equals to 0. Now just observe here, if a is equals to 0, substitute a is equals to 0 in equation number 4. What will happen? If a is equals to 0, this total term will become 0. This total term will become 0. If this total term will become 0, then we will get from this b is equals to 0. B is equals to 0, right? Now substitute a is equals to 0 and b is equals to 0 either in this equation or in this equation or in third equation. So what you will get, a is equals to 0 means this total term 0, b is equals to 0 means this total term 0. Then what you will get? You will get c is equals to 0. You will get c is equals to 0. Now just observe here. Just observe. If a is equals to 0, this is 0 into x square, plus if b is equals to 0, this is 0 into x plus 0, which is equals to 0. This equation will turn like this. Now just observe that one. For this equation, we are taken alpha, beta, gamma are the roots, right? Now if I substitute in this delta, one more root I am substituting here, delta. So what I will get, let us observe here. 0 into delta square, 0 into delta, 0 plus 0 means 0 plus 0 plus 0, we are getting 0 is equals to 0. Means here not only alpha, beta, gamma are the roots of this equation, delta also root of this equation. Not only delta, whatever it may be the letter you can take, whatever it may be the letter, either it is S or T or whatever it may be, either 5, 6, 7, numbers also you can take, whatever it may be, you can substitute in this, you will get 0 only. means this is not an equation. If I take more than 2 roots or the roots of the quadratic equation, then this is not an equation. This we call as identity. This we call as identity. This is not an equation. This is an identity. This is an identity. What is an identity? We already know. What is an identity? What is an identity? So just observe here. What is an identity? Now I will tell you here. What is a plus b whole square? A plus b whole square is a square plus 2ab plus b square. Right? Now just expand this one. It is a square plus b square plus 2ab, which is equals to a square 2ab plus b square. Identity means what? Here in place of ab, whatever the values you can take and you can substitute, you will get LHS equal to RHS. So that is nothing but identity, right? This equation, this a plus b whole square is equals to a square plus 2ab plus b square, an identity. You can substitute any value of a and b, this will definitely satisfy. So that's why we call it as an identity. Similarly, this is also an identity because you can substitute anything in x. In place of x, you can substitute anything. You will get 0 only. That's why if more than 2 roots are the roots of this equation, then this equation will turn into an identity. So that is a difference between equation and identity. This is an equation. For this quadratic equation, only 2 roots exist, because if I take more than 2, it will turn into an identity. So this is an identity, this is an equation. So that is the reason why we studied for quadratic equation we have only 2 roots. So this is the main reason. Okay, I hope you got this one. So what we did here, we have substituted the roots of the equation in the given equation. So I got these 3 equations. Okay, so after that what we did, 1 minus 2, 2 minus 3 and 1 minus 3. So I got 3 more equations. After that I have subtracted 4 from 5, and from that I got a equal to 0. And if I substitute a equal to 0, any of 4, 5, 6 equations, so we will get b equal to 0. If I substitute a equal to and b equal to 0 in any of these 3 equations, I will get c equal to also 0. Means here we are getting an identity if I take alpha, beta, gamma are the roots of the given equation. So that is the reason why we need to consider, we need to take, and that is correct only if we take only 2 roots for the quadratic equation. I hope you got this one. And now we are going to see what are the relation between roots and coefficients. Relation between roots and coefficients. So here we are going to consider ax square plus bx plus c is equals to 0 for this quadratic equation. Okay, we have alpha comma beta are the roots. Alpha comma beta are roots. Okay. Now just observe here. If alpha comma beta are the roots, so we can rewrite here ax square plus bx plus c, which is equals to, we can write as x minus alpha into x minus beta. X minus alpha into x minus beta. But if you observe here, what is x into x here? X square, right? X into x is x square. But what is the coefficient of x square here? The coefficient of x square is a. So here we are not getting a, that's why we need to take here a. Now if you observe, if you multiply x into x is x square into a is ax square. And for this quadratic equation, we have alpha comma beta are the roots. Now just observe here, if I substitute alpha in this equation, I will get 0 only. If I substitute beta in the equation, I will get 0 only. Means, so if I take a into x minus alpha into x minus beta, then this is nothing but ax square plus bx plus c only. Now what will happen if I divide this with a, means if I send this a to this side, so it is ax square plus bx plus c by a, which is equals to x minus alpha into x minus beta. Now if I divide with individually, if I divide with a, what I will get, x square plus b minus a into x plus c minus a. So which is equals to, now if I multiply inside, it is x square minus beta x minus alpha x plus alpha beta. Now if I take x common in these two, it is x square minus x into alpha plus beta I will get plus alpha beta. Now if I take here, if I rewrite this one as x square minus b minus a, otherwise minus of minus b minus a into x plus c minus a. Here minus into minus is plus only, right? Now here if you observe, just compare these two, what you will get, x square is there and x is there, x coefficient is here alpha plus beta and x quotient is here minus b by a. So we can take here, in place of alpha plus beta we can take minus b by a. And if you observe here, in place of alpha beta, means this is a constant term and here it is a constant term, alpha beta is equals to c by a. Now just observe here, alpha plus beta is nothing but sum of our roots only. We have taken alpha beta, right? So this is sum of roots. Sum of roots is equals to minus b by a, and alpha into beta means product of roots is equals to c by a. So this is the relation between roots and coefficients, right? Now here it is alpha plus beta and alpha into beta. So from these two we can easily solve alpha minus beta, difference between two roots. But here we have to consider absolute value only, because we don't know whether alpha is greater or beta is greater. So here that's why we need to consider mod alpha minus beta whole square. So what is alpha minus beta whole square? What is alpha minus beta whole square formula? Which is alpha plus beta whole square minus 4 alpha beta. Now what is alpha plus beta whole square? Alpha plus beta whole square is minus b by a whole square minus 4 into, what is alpha beta we got, which is c by a. So from this what I will get, alpha minus beta whole square, which is equals to b square by a square minus 4c by a. Now if I take LCM as a square, which is b square minus 4ac by a square, which is nothing but mod alpha minus beta whole square, but we want mod alpha minus beta, so which is nothing but b square minus 4ac root over by a. So this is nothing but alpha minus beta. Later we'll discuss what is root over b square minus 4ac. Already we know root over b square minus 4ac is our discriminant. So which is nothing but root delta by a is nothing but our mod alpha minus beta, which is root delta by a. Delta is nothing but our discriminant. We'll discuss later that one while discussing nature of roots. This discriminant only will decide the nature of roots. The two roots we are saying, what are the nature of roots, we'll discuss that one in the, by based on this discriminant only we are going to discuss that nature of roots. I hope you got this one. What is the relation between roots and coefficients? So that is alpha plus beta and alpha into beta and mod alpha minus beta. Here alpha plus beta is minus b by a minus coefficient of x by coefficient of x square. It is constant term by coefficient of x square, and here it is root discriminant by coefficient of x square. So this is nothing but our relation between roots and coefficients. Already you know this one. You already studied in your 10th class, but just we recalled that concept. Now we'll solve some problems based on this concept. What we discussed as of now. That based on those concepts, we are going to see some problems, right? Once observe this equation, first question, that is find k in the equation 5x square minus kx plus 1 equal to 0 such that the difference between the roots is unity. What is the meaning of unity? Unity means 1. Unity means here 1. Means difference between the roots is 1. So what is given here? Alpha minus beta, which is equals to 1 given. Mod alpha minus beta is equals to 1 given. If I take for 5x square minus kx plus 1 is equals to 0, alpha and beta are the roots. Alpha and beta are the roots. Alpha minus beta is equals to 1 given. But according to the concept, what is the sum of roots from this equation? Alpha plus beta is equals to minus b by a. Here minus b by a means b is minus k. Minus of minus k by a is 5. If you want, you can write here. A is 5, b is minus k, and c is equals to 1. Now which is minus b by a means simply it is k by 5. K by 5. Next, product of roots alpha beta. Alpha beta means what here? Product of roots means c by a. What is c here? 1. 1 by 5, which is nothing but our alpha beta. Now alpha minus beta is equals to 1. If I square on both sides, what I will get? Alpha minus beta whole square, which is equals to 1 square. What is alpha minus beta whole square formula? We already know. Alpha square minus 2 alpha beta plus beta square, which is equals to 1 square means 1 only. Now alpha square plus beta square, I will write a pair like this, minus 2 alpha beta, which is equals to 1. Now a square plus b square can be written as a plus b whole square minus 2ab, 2 alpha beta. A plus b whole square minus 2ab is nothing but a square plus b square only, right? So we have one more 2 alpha beta, which is equals to 1. Now alpha plus beta whole square minus 4 alpha beta, which is equals to 1. Now we already know what is alpha plus beta. Alpha plus beta is k by 5 whole square minus 4. What is alpha beta? We already know 1 by 5, which is equals to 1. From this we can easily solve. What is this? LCM is 25, right? It is k square by 25 minus 4 by 5, which is equals to 1. Yeah, the LCM is 25. LCM is 25. K square minus 5 means 5 4s are 20. 20 by 25, which is equals to 1. K square by 25. Okay. Minus alpha beta is 1 by 5. So which is what I will get here? K square minus 20 is equals to 25. K square is equals to, which is 25 plus 20, which is nothing but 45. So k is equals to root 45 plus or minus root 45. Okay. Now k is equals to what I will get? 3 root 5 plus or minus 3 root 5 we will get. Just observe here what is the question given. Difference between the two roots is unity given. So if I squaring on both sides, I will get alpha minus beta whole square, which is equals to 1 square. A minus b whole square is a square minus 2ab plus b square. I have written alpha square plus beta square as alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta, and one more 2 alpha beta is there, which is equals to 1. So we already know what is alpha plus beta, sum of the roots. From the given equation we can write sum of the roots minus b by a, which is nothing but k by 5. The product of the roots is 1 by 5, c by a. So I have substituted both and I got the value of k is plus or minus 3 root 5, which is k square by 25 minus 4 by 5, which is equals to 1. So if I take LCM here, 25 is LCM, k square minus 5 4 is 20, which is equals to 1. And from this we will get k value plus or minus 3 root 5. So in this way you need to solve the question, right? Once observe this one and we'll solve the next problem here. Let alpha comma beta be the roots of the equation x square minus 6x minus 2 is equals to 0 with alpha is greater beta if an is equals to alpha power n minus beta power n. For x is greater or equal to 1, then the value of a10 minus 2a8 by 2a9. This is the previous mains question. Okay, now how to solve this one? First of all, what is the quadratic equation here? It is given x square minus 6x minus 2 is equals to 0. Here x square minus 6x minus 2 is equals to 0 it is given. For this alpha comma beta are the roots he is saying. Alpha comma beta are the roots he is saying. If alpha comma beta are the roots of this quadratic equation, we can substitute these two roots in this equation. We already know. If, for example, one value is the root of an equation, if I substitute this value in this equation, it will definitely satisfy. If I previously we taken one example, that is x square minus 5x plus 6 equal to 0. We got roots 2, 3, right? So if I substitute 2 in the given equation, x square minus 5x plus 6, you will get 0. If you substitute 3, again you will get 0. Means we can substitute the given roots in the equation. That's why here I am substituting alpha comma beta in this equation. So what I will get here? Alpha square minus 6 alpha minus 2 is equals to 0. From this, and also beta, if I substitute beta, beta square minus 6 beta, okay, minus 2 is equals to 0. These two will helpful while solving this problem, right? Now listen carefully. So it is given that an is alpha power n minus beta power n. We need to find a10 minus 2a8 by 2a9. Now just observe here. a10 is nothing but alpha power 10 minus beta power 10. N value is 10, simply minus 2 into a8 means alpha power 8 minus beta power 8 by 2a9, which is nothing but alpha power 9 minus beta power 9. Now here I am going to write alpha power 10 minus 2 alpha power 8 as pair and minus beta power 10 minus into minus plus 2 beta power 8 by 2 into alpha power 9 minus beta power 9. Now in these two we can take common as alpha power 8. So if I take alpha power 8 as common, so here alpha square minus 2 we will get. If I take in these two beta power 8 common minus beta power 8, so here beta square minus 2 we will get by 2 times of alpha power 9 minus beta power 9. Now here alpha square minus 2, from this equation what is alpha square minus 2? We can write this 6 alpha. Alpha square minus 2, which is nothing but 6 alpha, and beta square minus 2 is nothing but 6 beta. So from these two, okay, now we can substitute here. So which is nothing but alpha power 8 into 6 alpha minus beta power 8 into 6 beta by 2 into alpha power 9 minus beta power 9 we will get. Now just observe here, just observe, which is equals to 6 into alpha power 9, it is 6 into alpha power 9 minus, it is 6 into beta power 8 into beta is nothing but 6 into beta power 9 by, here it is 2 into alpha power 9 minus beta power 9. So in the numerator if I take 6 common, what I will get? Alpha power 9 minus beta power 9 by 2 into alpha power 9 minus beta power 9. These two will get cancelled. And 2 ones are 2 3s are. So the answer is 3. The answer of this is 3. Very simple. This is the previous question. Very simple question, and it is repeated question also. So what you need to do? If alpha comma beta are the roots of this equation, so you need to substitute alpha beta. So from this you can write alpha square minus 2 as 6 alpha and beta square minus 2 as 6 beta. And we need to solve this one. And A10 means here alpha power 10 minus beta power 10 it is given. Right? And A8 means 8 we need to substitute. And after that we have to rearrange alpha terms and beta terms. And after that we have to take common. And here we need to substitute alpha square minus 2 as 6 alpha and beta square minus 2 as 6 beta. So we will get, at the end we will get alpha power 6 alpha power 9 minus 6 beta power 9. So if I take common as 6, so numerator and denominator will contain same terms. So if it cancel both and 2 ones or 2 threes, we will get 3 as answer. Very simple. And once observe this one and we'll solve the next question. Find the value of A for which the following equation has more than 2 roots. More than 2 roots. So for this equation, we need to find the value of A if this equation has more than 2 roots. Already we discussed that here you are observing x square, something into x square minus something into x plus something which is equals to 0. If you observe this, it looks like quadratic equation. So he is saying that for this quadratic equation more than 2 roots are there. He is saying, in the question it is saying. So if more than 2 roots are existed, then first of all we know that this is not an equation, this is an identity. Already we discussed that. This is not an equation, this is an identity. Why we are saying it is an identity? We got at the end that 0 into x square plus 0 into x plus 0 which is equals to 0. We got like this. Means simply he is saying that it is an identity, then find the value of A. He is saying for what value of A this will become an identity. He is asking the question simply. Okay. Now if you observe, if this is an identity, then this x square coefficient should be equal to 0. Means a square minus 5x plus 6 is equals to 0. And this a square minus 3a plus 2 is equals to 0. And 2a minus a square is equals to also 0. Now try to find the value of a in this. Already we know x square minus 5x plus 6. For this we got x equal to 2 and 3. Means a is equals to 2, a is equals to 3. Here it is a square 2a minus a plus 2 equal to 0. So if I have split the middle term here, if I take a common, it is a minus 2. If I take minus common, it is a minus 2. So means it is a minus 2 into a minus 1 is equals to 0. Product is 0, means a is equals to 1 and a is equals to 2. And if you observe here, if I take a common, it is 2 minus a which is equals to 0. Means product is 0, again a is 0 and a is equals to 2. 2 minus a equal to 0 means a equal to 2. Now we need to decide that what is the value of a so that this will become an identity. This will become an identity. Now we don't have to say that a is equals to 3, because if I substitute a equal to 3, only this will become 0, not this and not this. Total everything, this term and this term has to be 0. When this term and this term and this term, these 3 terms will at a time will become 0, means we need to check what is the common value of a. Here the common value of a is 2. Therefore the value of a is 2, so that this equation have more than 2 roots. Simply it is an identity. Okay, so I hope you got this one. So we solved 3 problems based on today's concept. Now I will give Three more questions. So you need to solve. Just try to solve it and post in comment box the answers.